So when you're graphing a rational, you have two different types of asymptotes. You have a vertical asymptote, which comes from your denominator, but you also have a horizontal asymptote. Okay, so the horizontal asymptote comes from your degree. So when we talk about degree, we're talking about, remember that degree is your highest power. That's your highest power, highest exponent. So there's three different types of situations you can have. You can have a situation where it is balanced. So that means that the highest exponent is the same. It's the same. So for example, if you have y equals 3x squared minus 7 over 2x squared plus 9. Notice how they both have a highest power of 2. So the highest power upstairs is 2 and the highest power downstairs is 2. So that means it's balanced. And when it's balanced, you divide the leading coefficients. So what's the leading coefficient in the numerator? 3. And the leading coefficient in your denominator is 2. So for this example, you would have a horizontal asymptote, and I'll write at the top because I know you can't see, and y equals 3 over 2. That's just for this example. So if it's balanced, you divide the leading coefficient. Now, if it's top heavy meaning that you have a higher power upstairs. So for example, let's say you would have y equals 3x squared minus 7, and instead of a 2x squared, it was just a 2x plus 9. So if it's top heavy, this is where we will have to do division. We're going to do synthetic division or long division. So instead of it being a horizontal, it's going to be a slant. So it's not horizontal. So for this one, it has a horizontal asymptote, meaning it's a straight horizontal asymptote. That's what I mean, horizontal. Okay? But if it's top heavy, it's going to have a slant. So it's going to have a slant. Like a line, y equals mx plus b. Now, bottom heavy, that means that the highest power is in your denominator. So going back, so this would say, for example, you would have y equals 3x minus 7 over 2x squared plus 9. See, all I'm doing is changing the exponents from each example. Whenever it's higher on the bottom, that's actually the easiest way, or the easiest to determine, because that's automatically going to be a 0. So you'll have a horizontal asymptote. So it'll be a straight horizontal, and it's automatically going to occur at y equals 0. You don't have to divide anything. You don't have to do division. It's just automatically y equals 0. So also on Friday, I passed out the study guide. There's a video explanation for the test review. So that's already posted. So you have everything you need to do well on this test. Okay, so let's go ahead and copy down a couple of examples. So we're going to look at a couple different balanced scenario. So these are balanced. So we're going to figure out where is the horizontal, because it could be horizontal or it could be a slant. So we're going to look at the degree, top and bottom. So I'll give you a minute to copy down these two examples, and then we'll discuss them. Okay, so it says, notice that for these two examples, can you see what I mean when I say balance? The highest power is 2, the highest power is 2. These are balanced. So you're going to divide your leading coefficients, which is 3 and 4. So you would have a horizontal asymptote at y equals 3/4. It would be a horizontal asymptote. Now, for this example, it's also balanced, but this is a special case because it's not a single fraction. So that is going to affect your horizontal asymptote. So you're going to start by dividing 3 and 1. So you will have y equals 3/1, and then you have to subtract that 4 from that. So it ends up being y equals 3 minus 4, which is y equals -1. And that would be your horizontal asymptote. Okay, let's go ahead and talk about bottom heavy. So because your highest power is in your denominator for this first example, again, it would be horizontal. So we have a horizontal asymptote, and this one would occur at y equals 0. You don't need to do anything with that. Just know that if it is bottom heavy, no constant is being added though, then it's y equals 0. This example, you see how you have this has an exponent of 0 and then an exponent of 1. So this piece is 0. But because you're subtracting the 4, this ends up being y equals 0 minus 4. So this has a horizontal asymptote at y equals -4. So if you have a constant being added or subtracted, it is going to move it. Okay. And then our last one we'll talk about is the slant, and that's where we're going to do synthetic division. So we could do long division, but it's a little easier to do synthetic. So we'll go through how to find that. So this has a slant asymptote. So you're going to take your denominator. This is where you would get your vertical asymptote. So if you take your vertical asymptote, where would it be? If you take this x plus 2 and set it equal to 0, what would you get? -2. So that's the number that goes on the outside. And then you list the coefficients of your numerator, which would be a 1, a 1, and a 3. All right, so you have to do this on the last test. Go ahead and do synthetic division. You're not going to end with a 0. So see if you remember how to do that. So we bring down that first number. That's going to be your slope. We multiply the -1 times 2. We get -2 and add. And this is my y-intercept. And that last number is actually irrelevant. So you just need the first two numbers. So your equation, because this is a slant, your equation for your slant asymptote is written as y equals mx plus b. So the first number you get is m. The second number you get is b. So the equation for your slant for this particular graph is y equals 1x minus 1. And we would have to graph that. So I'll give you a moment to copy that down. And we're going to go through the R. So originally there is a T in there. It spells Ratey, R-A-T-E-Y, but I took out the T. So we're going to go through the R, the A, the E, and the Y. Look at how your homework is set up, and you can answer the questions that way. Okay, so the first, so I'll give you a minute to copy it down, and then we'll go through it together. So wholes come from if you have quadratic divided by a quadratic. So do we have two quadratics being divided? Do we have an x squared over x squared? All right, so we don't have any wholes in this graph, so this has none. Roots, looking at your dark pink sheet, what does it tell you to look at for roots? At the top. Set the top equal to 0 and solve it. So if you take the x minus 4 and you set that equal to 0, what do you get? 4. So put a point on your x-axis at 4. This is the only place that the graph can cross through the x-axis. It's right there. A on your pink sheet, that's talking about your asymptote. So where does it tell you to look at for your asymptotes? The bottom. So take the x plus 2, set that equal to 0. And you write that as an equation. So that's going to be x equals -2. Let's go ahead and graph that. So you're going to draw in a dashed vertical line at x equals -2. So that line is a line that the graph is not going to cross. It's not going to cross x equals -2. The end behavior asymptote, that's your A. No, sorry. That's your E on your dark pink sheet. Is this one going to be balanced, top heavy, or bottom heavy? Looking at the degrees. Balance, right? So, because they're both x to the first. So you're simply going to divide the number in front, which is 1 divided by 1. So this has a horizontal. It's horizontal because it's balanced. And it's going to occur at y equals 1. Go ahead and draw that in. And then the last thing is your y-intercept, which is the y. Looking at your dark pink sheet, how do you figure out the y-intercept? What does it tell you to do? Put in a 0 for x. So your y-intercept is going to occur at y equals, so you're going to have 0 minus 4 divided by 0 plus 2. Go ahead and figure out what you get. And you get negative 4 divided by 2, which is negative 2. So we're going to put a point at 0, negative 2. And if you look at that, you already have enough to graph the right side of your horizontal asymptote. Keep in mind that these two are like guidelines. It's not going to cross it. So what you're going to do is just draw a line. It's really close to my blue line, then it crosses through my x-intercept, crosses through the y-intercept, and then it goes straight down. So we need to make a T-chart. We need a couple points to put in on the left side of the asymptote. So let's pick a couple of numbers over here. So let's go ahead and put in negative 4. Well, no, let's put in negative 3. Let's put in negative 3, and then let's put in negative 5. And I just want you to know, so when you're doing this on the test, I'm picking any numbers on the left side of negative 2. So you just need to pick numbers on the left side of negative 2, numbers less than negative 2. So I'm going to use negative 3 and negative 6. Yeah. So let's figure out what you get when you put in negative 3 and negative 6. So go ahead and put in negative 3. So that would be negative 3 minus 4 over negative 3 plus 2. See what you get. And then do the same thing with negative 6. Negative 6 minus 4 over negative 6 plus 2. See what you get. So go ahead and get your two y values. Any questions about why I picked those two numbers? Did you have to pick those two numbers? No. You can pick any number, because I know your test is Friday, so we don't have a lot of time to work with this. Any numbers less than negative 2. So for the first one, you would have negative 7 divided by negative 1, which is positive 7. Go ahead and put a point at negative 3, positive 7. Right there. And then go ahead and see what you get for negative 6. That one might be a decimal. So 10 divided by 4 is 2.5. Who got 2.5? 2.5, okay. So -6, we're going to go up 1, 2.5. So that's about right there. And you can put in more points, but I know that because I have these two boundary lines, I cannot go through these lines. So it's just going to kind of, and I probably should have picked something in between, but it's okay. The main thing I'm going to look at on your test is, do you have the R, the A, the E, and the Y? That's the most important thing. I'm going to look at this information right here. And then making sure your graph does not cross through your asymptote. Okay, so I think we got time to do one more. Anybody need more time to copy down this first one? Okay. I want to do this one. Let's do this one. Go ahead, copy that down. And I'm just writing down the 5 things that's on your homework. Homework 15, which is due Thursday. And homework 15 is set up the way the test is set up. So you'll have a graph and you'll have to answer those 5 questions. So this one is a quadratic. Go ahead and factor, because we will have a whole. Factor top and bottom. Something should cancel out. So what does x squared minus 4 factor down to? Thank you. X minus 2, x plus 2, so that's the top part. Your denominator, you need 2 numbers that multiply to be -8 and add to a -2. 2 numbers that multiply to -8 and add to -2. Anybody know those numbers? -4 and +2. So does everyone see how something is going to cancel? When this happens, when something cancels, you have a whole. Okay, so this is what we're actually going to use. We're actually just using this because we're going to remove that factor. And that's going to leave us with x minus 2 over x minus 4. So let's go ahead and figure out where our whole is located at. So to figure out where the whole is located, you're going to take that x plus 2 that you canceled out, set that equal to 0. So if x plus 2 equals 0, you get -2 for x. Now take this -2 that you got, and I want you to put it in this function. So put your -2 here and here to get the y value. So again, whenever something cancels, you set that factor equal to 0. Whatever cancels, set that equal to 0. And then substitute that number back into the function. So if I substitute that negative 2 back in, I get negative 2 minus 2 over negative 2 minus 4. So that's going to be a negative 4 over a negative 6, which is about 2/3. Positive 2/3. So let's go ahead and put an open circle on our graph at negative 2 2/3. So that's really just like negative 2 between 0 and 1. So I'm just going to put an open circle right there because that's the whole. And now you're going to go to your dark pink sheet and answer these 4 questions, but you're using this. So this is my function that I'm using to graph. So your roots are going to come from the top, which is just x minus 2. The vertical asymptote comes from your denominator, x minus 4. So you're using this here to answer these 4 questions. So let's go ahead and do that. So our roots, if x minus 2 equals 0, we get positive 2. Put a point at 2, 0 on the x-axis. Your vertical asymptote comes from your denominator. So what is that going to be? X equals what? Where's your vertical asymptote going to be? X equals 4. Let's go ahead and draw that in. This is balanced. So you're dividing, again, this happens to be 1 divided by 1. So you have a horizontal, this is horizontal, it's not a slant. And that's going to occur at y equals 1. And your end behavior asymptote, substitute in a 0. So that's going to be 0 minus 2 over 0 minus 4. So that's negative 2 over negative 4, which is 1/2. So your y-intercept is at 0, 1/2, or 0.5. So that's about right there. So you can kind of see on the left side that we have everything we can do. You're going to just come really close to your asymptote, skip over that hole, that's your removable discontinuity. And then it's going to go towards 4 where you have an infinite discontinuity. So we don't have anything on the right side of the asymptote, so let's pick 2 numbers. So somebody give me 2 numbers to put in. 2 numbers on the right. 5 and 6. Okay. So go ahead and type in 5 and 6. Put your 5 in, take 5 minus 2 over 5 minus 4, see what you get, and then do 6 minus 2 over 6 minus 4.
So ever since we used the new function with the whole, that's the function we got.
Exactly. Mm-hmm. So what did you get? Val, did you get a number for 5? 5 minus 2 over 5 minus 4? What'd you get? 3 over 1. So we're going to put a point at 5, 3. So 5 up 3, 1, 2, 3. So that's right here. and then 6. So that's 6 over 2. 6 minus 2 is 4. Did you get 2? My brain isn't working this morning. Is that what you all got? Everybody else got 2? Okay. So we're going to put a point at 6, 2. So again, you're limited in what you can do because you can't go through the red line or the blue line. So all I can do is go straight up really close to the red line and then curve and ride along that blue line. And that is your graph. So this one has a removable discontinuity and an infinite discontinuity. All right, we'll end there, and tomorrow we'll do a couple more graphs. So we did numbers 1 and 2. We did questions like numbers 1 and 2 on your homework. Homework 15.